Hello team, I'm hoping I'm live. I'm having a little technical difficulties at the moment, as you can see. Um, but maybe you can't see, so I don't know. Um, I'm really desperately trying to get my whiteboard functioning right now, and it's decided not to play ball, which is kind of frustrating. So I am going to continue this via Desmos. Let's hope Desmos works for me. So let me know if you can see my Desmos screen. Okay, that should be full screen now for you. Okay, all right. So if you can't see my Desmos screen, please let me know and I will try to do something. Hello, hello, hello. Ooh, perfect, outstanding. All right, so let's have a look at some graphs. So when we try to draw graphs, what's really important is what the functions look like. And now I want to call back to something we did in level 1, which was to look at quadratics. Okay, so I'm going to write, we've just done some algebra as well, so I'm going to just write the standard form of a quadratic into here. Y equals ax squared plus bx plus c. Okay, that is the standard form of a parabola. I'm hoping this is clear for you. I'm sorry, my whiteboard literally worked for my year 13s, but has decided not to work for you guys. So this is how a standard, this is the standard form of a parabola. Now, I don't want to use the standard form of a parabola because that's not very useful for us to draw. But from the standard form, what we can do is we can factorize it. Okay, you can't see any edits into Desmos. That is quite frustrating. So let's go back to here and I will try to make this make sense. So you can hear me, but you can't see any edits that I'm making on Desmos. So this should work. So nope. Sorry guys, give me 1 second. Technical difficulties are the worst, and I honestly don't know why I'm having them. But I might try to. I don't know how to restart the stream, so I'm gonna just. Okay, so we're gonna use this screen. Okay, so you can't see anything just yet, but hopefully you can see something now. All right. Let me know if you can see something. Sorry, guys. I had this all working and now it's just gone kaput on me, which is rather unfortunate. So, can you see Desmos loading now? Just let me know. Sorry, I don't know what's going on. I don't know how to restart this stream, so I'm just going to continue. Can you see this, guys? Let me know, please. And if not, I will restart the stream. I've not faced technical difficulties like this before. We're all learning. We all make mistakes, and it's okay. So, look at this standard form of an equation. Y equals ax plus b, ax squared plus bx plus c. Oh, praise the Lord. Can you see my edits on it, though? Oh, praise the Lord. Oh, this is so good. I'm not sure how this happened, so sorry, guys. So the form I'm going to use is I want to use a factorized form. Perfect. Okay. So I want to factorize and have a factorized form. And so what I'm going to do is I'm going to write f of x, because I like function notation. And I'm going to go function notation, and I'm going to use k, and I'm going to have x minus m and x minus n. And so I've got 3 unknown variables, and I've just given them some numbers right now. Okay. I'm going to just try to make this full screen, see if that works, and also change that to projector mode so it's a little bigger. Okay. So k, m, and n. M and n are the roots of my equation, and we've done this in algebra, and so that shouldn't be too much of a surprise. So I'm going to pick m as 5, and so now you can see this graph goes through 5, 0. And I'm going to pick n as -3. Now you can see this graph goes through at -3, and it goes through at 5. And those become my x-intercepts. Okay, but this k value is a scale factor, right? So I'll just try to write that, scale factor. So a scale factor tells you how squished or how expanded something is. Yeah, not M and M, but M and N. So we'll determine how much each point is scaled vertically from the standard form. Okay, and you're like, Mr. Dharma, what does that mean? Well, let's have a look. So I'm going to pick M and N as nice numbers. I'm going to go -1 and +1. Right? And I'm going to zoom in a little bit. Okay? And I'm just going to change these that I'd already set up. So unfortunate. Oh well, but you can still see this, right? So here we go. If I change k up, I'm just going to change this from -4 to 4. We'll go steps of 0.5. All right. So what happens? As k gets bigger, look at what happens to each point. So this point now goes further down. These two don't change. What happens when k is 2? Now this point is twice as what it was here. When k is 4, that point is 4 times as far as it was when I was at the start. And so it's a scale factor. What happens when I go negative? What happens at -4? Well, it's upside down. And what about -1? Well, it's the same as the graph we had before, but it's upside down. I'm just going to draw the graph we had before, just so you can see the difference. Right? The blue graph is the graph we had before. And look at how this graph compares to the blue graph. So if it's positive, it's the same. Stretched vertically in the negative direction. And so a negative just flips the graph. But the x-intercepts will not change. And I think that's pretty cool. What I want to ask you is, what would happen if k became a fraction? What happens if k is a half? What would happen to my graph vertically? Well, let's have a look. So I'm going to make k equal 1/2. And you can see that the purple line, every single point, the height is half of what it was. So here it was 2, and now it's, here it was 4, so the y value was 3, and now it's only 1.5. Here the height was 1, now it was 0.5. And so you can sort of see that every value has halved. And that's what this k value does. It's a scale factor. And as I change m and n, I can move my graph around. And so, not y equals half, k equals half. So let's have a look. I'm going to make one of my roots be 2 and another root be -3. Look at how my graph has changed. It goes through this point and it goes through this point, and my k is still 1. And so my equation for this is 1, I don't need to write the 1, x minus 2, x minus -3, so that's the same as x plus 3. Okay, and I should make k1. Okay, and that is my graph. And that's really it. So parabolas are really interesting. If you know the two roots and you know the scale factor, you can draw them. Parabolas also have a symmetry. They have a symmetry going down the middle. Okay, and that symmetry is halfway between the two x-intercepts. So let me pick some nice x-intercepts. So -4 and 2. Get rid of this thing. And I am going to zoom out a little bit more. No, I'm going to zoom in a little bit, and I'll make this 1, and I'll make this -2. Let's zoom in a bit more. If I have 1 and -2, what's halfway between them? Well, if you can look on the graph, halfway between this and this is at -half. You can sort of see it here. And if I plug in -half into the equation, I will be able to find out when its turning point is. And so if you think about what we were talking about the other day, let me see if I can write the 5 properties of this graph. So here goes. Properties. List them out in the comments if you can. Let's start with symmetry. There is a line of symmetry through x equals -0.5. Let's try another thing. 1, 0 and -2, 0 are x-intercepts. Yeah? See if you can list them out, like actually write what they are. What is the minimum? The minimum is -0.5, comma, -2.25 is the minimum turning point. Okay, how many have I got? I've got symmetry, I've got x-intercepts, and I've got turning point. I now need to write the domain and the range. Okay, and so this one's going to get a little, I'm going to write the domain separately. I'm going to write the domain up here. The domain, well, what x values can I use in this function? And I would say that everything is in the domain. Domain, all real numbers. What about the range? Well, for this one, well, given that the minimum point is at -2.25, I can't get values below -2.25. So I'm going to say that the range is going to be, there's my curly bracket, y is greater than or equal to So I can't do that symbol. I can if I just do y is greater than or equal to 2.25. And that becomes my range. Okay, don't worry about the triangle there. The triangle is a bit confused. So, and I mean, if I got rid of those curly brackets, we would get a pretty interesting. Sorry, that's meant to be negative. Okay, that is the range. I'm gonna put curly brackets on, otherwise it does weird things. Okay, that's the domain, that's the range, that's the symmetry, and that's the x-intercepts, and that's the turning point. That's how parabolas work. And depending on where I put my x-intercepts, I can change the rest of the parabola. But a really interesting thing is, based on the x-intercepts, I can work out the turning point quite nicely. Okay. So, what I'd like for you to do is I'm going to give you a function. So I'm going to just change these things up a bit. And I would like you to write what each of these properties are. And I'll wait and then we'll do them together. All right, so in this second graph, I'm going to change n to be 2 and n to be -3. And I'll change k to be 0.5. Okay? I want you to, based on the graph here, I want you to tell me what the symmetry, the line of symmetry is. I'm going to just change this one a little bit more. I'm going to change this to -1. There we go. I'll change it to 3. Okay. I want you to tell me what the symmetry, the x-intercepts, the turning points, and the domain and the range are for this function. Let's go. All right. I'm going to give you about 2 minutes, and once you've done that, then I'm going to carry on. What I might do is, just to give you a little bit of help, I'll just highlight these points for you, just in case you need them. Okay, I'm going to leave that there. I'm going to just pause my mic for a second whilst I try and figure out how to get my whiteboard working. All right, team, that whiteboard ain't never coming back today, so we're going to have to do this without whiteboards today. I'm sorry. So we've got the line of symmetry through 1. Yep, I like that. So I'll write that through x equals 1. Nice. What else do we have? All right, team. Kind of want more of you to write stuff in here. What are the x-intercepts? For me, the x-intercepts are -1, 0, and 3, 0. And the turning point is, well, if I plug in x equals 1 into this equation, well, if I plug in x equals 1 into my equation, it comes out as -2. So that is the minimum again. the domain is all real numbers, and the range is y is greater than -2. Yep, fantastic, Barack Obama. I'm not sure who you are, but this is fantastic. Okay. Now, that's parabolas. That's how you plot a parabola. That's how you draw a parabola. And you're like, Mr. Dharma, why is this useful to us? There we go. Nice, nice. Hey, I want you to write the x-intercepts as coordinates, just like you've done the turning point, Angelina. But I'm just going to come back and show you a few things, okay? So I'm going to get rid of these. Okay. Now I'm just going to write in a function for you. I'm going to say f of x equals 0.5 x minus 1 and x plus 3. Okay, that's my function that I want. Okay. Yeah. Okay. Now look at my function. And suppose I wanted my function only in the positive half. I could insert a domain. I could say my domain is equal to x greater or equal to 0. And I could try and get all of that in my function, and that only being the part. So what I'm going to do is I'm going to go up here, right next to the graph. I'm going to just move this out so you can see. And next to it, I'm going to write x is greater than 0. Can you see that now I've only got the positive part of this function? So actually, you can set the domain in here, right? Let me change the domain a little bit more. How about if I only wanted from 1 to 3, x equals 1 to x equals 3? I'm going to write that. 1 less than or equal to x, which is less than or equal to 3. And now I've set the domain for my function on Desmos so that it only gives me this graph. This is still the parabola, but only between here and here. Okay? If the domain is between 1 and 3, can someone tell me what the range is right here? Be very curious. Okay. The domain is from 1 to 3. What is the range? All right. Yeah, so the range is from 0 to 6. And so you have a range that is the y values. How far up am I going? I'm going from 0 all the way up to 6. And you're looking at the y values only. Okay, and so that's how you could use domains and ranges of a function. Now, there's a few things that you can do with parabolas that I'm going to let you do from now on, but I want to actually cover something more. I think I've done enough on parabolas. Yeah, exactly, Angela, Barack Obama. It's kind of weird talking to Barack Obama, but that's fantastic. So, I want to show you something wild. So, if this function is my general function, right? Where, let me just move this closer, where m comma 0 and n comma 0 are my x-intercepts. So if I move 1 to here and 1 to here, m, 0 and n, 0, those are my x-intercepts. My turning point is halfway between them, right? And so sometimes you might want to note that your turning point is the average of those 2 points. What's the average of m and n? M plus n divided by 2. Comma, what's the vertical part of that? Well, that is f of m, whatever the function's value is at m plus n divided by 2. Right? Ain't that some crazy stuff? So if you want, you can write these algebraically. And if you understand how they fit together algebraically, you could change m and n however you want, and you would always have all 3 of these points quite nicely. And you could always say that the line of symmetry goes through m plus n divided by 2, and you could also always say that these are the x-intercepts, and this is the turning point. And you're quite almost done, and then you just got to figure out what your domain and your range are. Okay, but I'm going to get rid of these. I'm going to ask you, what would happen if I put another thing on the end of this? So I have x minus n. What if I did another letter? X minus another letter. X minus p. I'm not going to add slider until you guys tell me what you think it will make. And so it will make a cubic. Look at this crazy looking function. It starts at the bottom, goes up a little bit. It's not a sine wave, John, it's a cubic. Starts at the bottom, goes up a little bit, comes down, goes up a bit. And can you notice that these are your 3 roots? Okay, so your 3 roots are 2, 0, which is whatever m was, and then you have 1, 0, and you have 0, 0. Okay, so those are your 3 roots, and I can change them around. And now I just have 3 roots. Okay, so as I move them around, my function changes quite dramatically. That's true. Let me just do something so that it doesn't do anything dodgy. So watch this. You prepare to be amazed. So if p was there, okay, I'll get rid of these ones. These ones don't help me. So p, now we've got 2 roots there. So that's why it only hits once there. And here's the other root. What about if p was 0? Now it hits twice there. So it's sort of like just one parabola there. You got 2 roots there and 1 root there. What about if p was a negative number? Look at this crazy stuff. 1, 2, 3. But the function now has 3 roots. So cubics are the same as parabolas, except they have 3 roots. So for your properties, right, you still have your x-intercepts, but this time you have 3 of them. You have your turning points, but now you have 2 of them, which are there and there. And how do you find them? This time we just find them by looking at your graph. I wouldn't try to find them algebraically. It's a bit too hard for now. You've still got a domain. For this one, the domain is all numbers, all real numbers. And you've still got a range. What am I missing? Oh, also, as you change k, your graph gets stretchier or flatter. And if k is negative, it's upside down. Same as before. But k is just a little bit more hypersensitive now. So you've got to be a little bit careful with how you do stuff with k. But I don't think it matters too much. What do you think is missing in my properties? What have I not talked about? Yes, Najaya, yes. So there is no line of symmetry. So cubics don't have lines of symmetry because they can't be mirror reflections of each other. Okay, so cubics won't have lines of symmetry. Cubics do, however, have points of rotational symmetry, but I don't really want to stress that, okay? Because they do have a rotational symmetry. They have a point of rotational symmetry somewhere in here. Let me make my equation a little bit nicer. Like here, the rotational symmetry point is at 0, 0. Yeah, thank you, Rohan. Yeah, so this has rotational symmetry of 180 degrees at 0, 0, but I think that's less important. So typically what you want to say is there's no line of symmetry for cubics, because cubics are not symmetric rotationally. They are, but reflectively they are not. And that's kind of interesting. But all your x-intercepts, they're the same. Your k does the same kind of thing. And so you're like, Mr. Dharma, what can I do? Well, if I give you a function or a curve or something to graph, I'm going to just leave this here for a sec, and I'll just see if I have something that I could put on here so that we can have a look at. Sorry, I don't know if that's ruined what you've seen. Probably has. I want to draw a curve that I won't tell you what it is. So watch this. So I'm going to get rid of all of this. I'm going to hide my screen for a minute. And I'm going to plot something. Okay. And I've plotted something that is pretty weird looking in my computer. And you're going to have to come and have a look and tell me if we can put a model on it. Okay, we're going to try and model it with a parabola or a cubic. Okay, so can you see my screen yet? I'm sorry guys, I had this whole thing planned with a whiteboard, but for some reason whiteboard decided not to be my friend today. Okay, so you got to bear with me. So I have this. I'm going to draw the equation of a parabola, f of x equals k, x minus m x minus n, and I'm going to try and fit this. I'm going to change this color. I'm going to change this to a red line. I want to try and fit this red line to this blue line. Okay. What do you think the domain should be? What do you think the domain eventually should be? Look at the blue line. Where's the domain of the blue line? Yeah, the domain of the blue line is from 1 to 5. And so eventually I am going to put a restriction and say my domain is from 1 to 5. But I want to try and draw a parabola. Okay? And do you sort of see how it's got an x-intercept here, the blue line? So I want to have one of my x-intercepts here, and the other I want to have quite far away. So maybe I'll try 12. So one of my x-intercepts is 1 and the other is 12. Does that look like the blue line? No. What I'm going to do is I'm going to make k negative. Does that look like the blue line? Once again, no. Because it's way too big. Right? What I might do is I might make that just 11 for now. And you're like, Mr. Diamond, why does that make that much of a difference? It really doesn't. But what I'm going to do is I'm going to make k a little bit smaller. Okay? I'm going to make k 0.5. Does that look like the blue line? Not quite. What about if I halve it again? 0.25. If I halve it again, 0.125. Oh, hey, it kind of looks like the blue line. I'll just increase it by something. I'm going to make it 0.13, 0.14, 0.15. Yeah, I'm going to make it 0.13, 145. There we go. Oh, look at this. I've got this red line that I'm modeling, and I've got this blue line that I'm going to just put my red line behind. So can you sort of see that I've modeled this red line, this blue line, by using my red line? And so what is my equation of this red line? Let's try write it. Y equals negative 0.145 x minus my first root, which is 1, close brackets, x minus my second root, which is 11, close brackets, and that is my graph. And it looks pretty good, and I'd say it looks pretty good from 3 to 5, but it looks pretty not great from 1 to 3, but then it's like, I don't even need it outside of that range. And so what I'm going to do is I'm going to put my domain in here, and I'm going to say put my domain as 1 to 5. And would you look at that? This is my model. The green line models the blue line, and that's a fairly cool model. And is it perfect? No. But that's what I'm trying to do here. I'm trying to model something, and we'll see. And so now I'd say for my model, let's have a look. I have got how many x-intercepts? Well, I had one x-intercept, x is 1 and x is 11. So 1, 0 and 11, 0, but I'm only using one of them. Is my turning point of my parabola in this thing? No, it's not. So that's pretty interesting. So you say my turning point of my parabola is not in this. Okay, but it's really good to list them out before you put your domain on. So, I'd have this and I'd say my parabola's turning point is 6, 3.625. Please close the bracket. Barack Obama, I will go back to closing it in a second. But first off, I'd list off all the properties of the parabola, and then I would go and... You can't see, but the bracket is closed. Otherwise, it wouldn't have worked. I'll just make this bigger so it looks like it. Okay, there we go. So that's what we're going to get to. We're going to try and model things. I know this might have been a bit too much, but what I can do is I could have modeled this with a cubic as well. And maybe my cubic will look a little better. So I want you to practice having a look at this, playing around on Desmos. So go to desmos.com, do what I've done, give yourself a random looking curve, or import a picture. I don't know, import I don't know, some curved picture like, I don't know, the McDonald's sign, or like Carl's Jr.'s logo, and see if you can model it. And we'll see what we can do. Your teachers will give you activities to do along these lines, and all I'm saying is this is what we're going to get to. We're going to understand how each of these functions work, and then we're going to model them. And it's not going to be perfect. Like, look how terrible this is. But we're going to practice, we're going to refine, and we're going to get better. Does that all make sense, team? Please say yes or no. And whilst you say yes or no, I'm going to try and fit a cubic model. Okay, no one's really saying yes or no, so I'm not sure. Alright. So cubic model. I am also going to keep everything the same, but I'm just going to make P some like huge number. Negative number. Negative 40. Okay, Monique, what's alinear? Right? And so if I look at this, it's kind of terrible. But I'm just going to drop this down, and actually I'm going to divide it by 10. Oh, look! It's kind of okay. So I've got to have a bit of a play around with this and see what happens. So yeah, what I'm trying to get at is, okay, I'm gonna throw this away because this looks a bit scary. Because this is a bit gnarly. I'll get rid of all of this. No, lines of symmetry have to be equations of. Lines of symmetry have to be equations. If you take out f of x of the equation, what happens? Nothing. It's just a better way of doing it. So okay, for some, like what I'd say is, I would recommend going and having a tutorial with your teacher just to identify what's like the minor things as to what's going on. But what we're doing is we're forming models of parabolas, right? So parabolas, okay, let me get rid of this as well. Parabolas are in this form. Y equals, or f of x equals k, x minus 1 point, x minus another point, okay? And that's a parabola. And all I need to do for a cubic is add another bracket with x minus p. Okay? Once I've done that, my cubic will look something like this. If I change m and n, it will kind of look like this curly looking equation. And if I just had a parabola, it would look like that kind of equation. And all I want you to do for now is practice drawing parabolas and cubics. Later on, we'll look at modeling them. Okay, I don't want us to think about modeling them just yet. I just want to practice drawing parabolas. Okay, know what the x-intercept is, know what the y-intercept is, know what the turning points is, and know whether there is symmetry and identify what domain and ranges are. Okay? Then we will come back to modeling this. Okay, so I know this last part would have been a little tricky, and that's okay, but feel free to send me an email if you're confused, and I will talk to you later on. Does anyone else have any questions? Najaya, there is no classroom code for Desmos students yet. Your teacher will give you one tomorrow, possibly. Um, if you're in my class, you haven't got that yet because I haven't asked you to do this kind of stuff just yet. We will do that tomorrow. So just wait for what your teacher uploads. You can just go to normaldesmos.com and try these. Okay? I'll catch you guys later. Thank you. Bye for now. Ava, I think I answered your question. Lines of symmetry are written as equations.